Hello everyone, my name is Atish and topic of this learning video is application of matrices to solve differential equations. In the so many videos earlier, we have seen numerous applications of matrices, whether it is in image processing, in communication system, in designing of the bridges, and in designing of the car stereo system. There are so many applications we have on matrices. In today's class, we'll discuss the mathematical application of matrices, and this topic is nothing but on the application of matrices to solve differential equations. Okay, so as you know that we have three different methods to solve the differential equations with the help of matrices. These methods are matrix method, method of expansion, that is expansion method, and the Sylvester theorem method. We have already seen matrix method, and as you can see, I have highlighted expansion method in this slide. So we are going to learn the expansion method in this learning video. Now you may be wondering that we have matrix method, we have expansion method, and we have Sylvester theorem method. So which method we should apply? So let me tell you in particular for the expansion method. If the eigenvalues are repeated, you have to use the expansion method. Okay, so let us go for the working rule. So the working rule says, so the working rule comprises of 5 steps, and these steps are: write down the given equation in matrix form, find out the eigenvalues, check the nature of eigenvalues, apply a method of expansion, and use solution of matrix to get the answer. Now as you can see, these two steps are as it is. Now we have these first two steps are as it is that we have in the matrix method. Okay, but there is something new in this: check the nature of eigenvalues. So you need to check whether the eigenvalues are repeated or not repeated. If repeated, method of expansion is applicable. Okay, and then we'll apply the method of expansion to get the answer. Okay, and then we'll use the solution of matrix form, the matrix form that we'll be getting in equation 1. We'll use the solution for it to get the final answer. Okay, so without wasting much time, let us take an example. So the example number 1 says, solve dx1 by dt is equal to x1 plus x2, dx2 by dt is equal to x2. Okay, as you can see, this x1 and x2 are dependent on t. So what we can say, x1 and x2 are dependent variable, where t is independent variable. Okay, and we are given the initial condition: x1 0 is 1 and x2 0 is 1. These initial condition will be helpful in finding out the constants. Okay, so when you use this initial condition, there will be no constant in the final answer or in the final solution. Okay, so this x1 0 is equal to 1 implies when t is equal to 0, x1 is 1, and when t equal to 0, x2 is 1. Okay, so let us take a solution for this. So what is the first step? Do you remember the first step? The very first step says, write down the given matrix in the given problem in the matrix form. Okay, so the given system of equation can be written in matrix form as ddt common from both the side, from left hand side, and we remain with x1 x2. Now next you have to write down the coefficient matrix. So what is the coefficient of x1? 1. Coefficient of x2? 1. Then in the second one we don't have coefficient of x1, meaning thereby coefficient of x1 is 0 and coefficient of x2 is 1. Okay, now if I denote this x1 x2 eigenvector as capital X, so I will be getting dx by dt is equal to ax. Okay, where what is x? X is equal to x1 x2. Okay, now what is the next step? The next step is to find out eigenvalues, and eigenvalues are given by the characteristic equation. So characteristic equation is given by determinant of a minus lambda equal to 0. Now subtracting lambda from the diagonal element and rest of the element as it is, take the determinant. Okay, now solving this is nothing but cross multiply, 1 minus lambda into 1 minus lambda minus 0 equal to 0. Okay, now solve this further. So we'll be getting 1 minus lambda into 1 minus lambda equal to 0. Okay, so what values we are getting? 1 minus lambda equal to 0, 1 minus lambda equal to 0. So lambda equal to 1 and lambda equal to 1. So for the sake of our convenience, we'll write this first eigenvalue as lambda 1 and second eigenvalue as lambda 2. Okay, this completes our step number 2. Okay, now what does step number 3 says? Check the nature of eigenvalues. So as you can see that the eigenvalues are repeated, so you just need to write down one sentence here as the eigenvalues are same or eigenvalues are repeated, hence method of expansion is applicable. Okay, this completes your step number 3. Now the next you have to use the expansion, method of expansion. Before that, let me go back to the slide. Now we need solution of this method to get the final answer. So solution of this method can be easily gettable by separating the variable. So when you separate the variable, take dx and x on one side and a dt on the other side. So we'll be getting dx upon x is equal to a into dt. Okay, now integrate this. So dx upon x integration is log x, a coefficient matrix constant, integration of 1 dt is t plus log c, and then you take log c to the left, so you'll be getting log x minus log c, apply log a minus log b formula, you'll be getting log of x by c is equal to at. Okay, then x is equal to, remove the log, so you'll be getting x by c is equal to e to the power at. So x is equal to e to the power at into c. So this is the solution that we have. This x is equal to e to the power at into c. Now what is this c? This c is nothing but the matrix of initial values that is given to us, x1 0, x2 0, and these values are given in the problem itself. Okay, now substitute. What is x? X is nothing but my vector, column vector comprises of x1 x2. E to the power at can be written as, just like we have the expansion of e to the power x as 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. So in place of x we have at matrices. Just because we have matrix A, so instead of 1 you have to replace it by a identity matrix. Okay, now solve this. Just putting I is equal to 2 by 2 matrix, then A matrix, then A square matrix, and then you solve this bracketed quantity. So what you can do is, this remain as it is, then when you multiply this t to this matrix, you'll be getting t 0 t, then here t square by 2 factorial, 2 into t square by 2 factorial, then 0, then t square by 2 factorial. So you'll be getting the matrix and then add, so you'll be getting a matrix like this. Okay, now if you remember, this is nothing but the expansion of e to the power t. So this is e to the power t, this is 0, this is e to the power t. Now you may arrive at a question then what to do here. So you need to take t common from here and you will remain with 1 plus t square by 2 factorial and so on, if you write down the further steps. Okay, if you write down the further terms, so just replace it. So this is x1 x2 e to the power t, t into e to the power t 0, this is e to the power t 1 1. Okay, so solve this. So e to the power t into 1 e to the power t plus t into e to the power t 1, then here 0 into 1 0 plus e to the power t. So what we get? We get x1 as e to the power t plus t into e to the power t, and x2 is equal to e to the power t, and that is what we want. Okay, so this is nothing but the solution of the given problem. Okay, so I hope this video lecture is making sense. So thank you for watching this learning video. Go through the problems that we have taken in this video. You can solve such type of similar problems, and if you have any doubt you can contact me at any point of time. Okay, I will be helping out help you out if you are getting any difficulty. So thank you for watching this learning video. Enjoy learning digitally. Thank you.